Hi there, Nick here, M0NTV, and welcome back as always to my shack and to what will be my final homebrew video of 2023. And hopefully, he says, in faith, a short one. We live in hope, don't we? Because really all I want to do today is to show you where I've got to and what it looks like when I put together all these different modules that I've been building over the course of the year. So that's the whole of the IF stage with the microphone amplifier and the bandpass filters, and yeah. And we're going to do some initial transmit testing as well, so you can see how it all plays together and performs. So here's the plan. I'm going to show you the block schematic in a moment of where I've got to in the building of the radio and what lies ahead still to do. Then I'm going to show you what it actually looks like, because I've been taking all these separate little boards and stacking them together, because I've got to shoehorn it into that small, for me, blue enclosure, remember. And then, when you've seen it, we'll fire it up and we'll do some tests so you can see how well it's doing. So, as always, I hope you find something of interest here and I hope you enjoy. Okay, so I've got my humongous cursor here, so hopefully you can see what I'm pointing to. So here is the architecture of the rig, and at the moment we're only really concerning ourselves with the transmit chain. So we built the microphone amplifier with the compressor. That's going to a relay then into the balanced modulator. And the balanced modulator, of course, is being fed via an Arduino by an SI5351, so two clock outputs. Clock 2 is going out to the modulator here, clock 0 is going out to the transmit mixer, which we'll get to in a minute. So we're going through the modulator and then into the IF section, and you'll remember we've got these bi-directional amplifiers, so we're only really concerned with the red side at the minute, which is the transmit arrows. So we're going through one stage of IF amplification, then to the crystal filter. I'm not going to talk about the crystal filter. I will link below to my video that I made called Crystal Filters for the Fearful, because the crystal filter I built for this radio is identical to the one that I built in that video. So if you want to know how I built that one, then go ahead and watch that. And then it goes to another stage of amplification and then into the transmit mixer, which mixes the transmit signal from the IF frequency up to the transmit frequency. And then I built another stage of amplification, and this is going to do double duty. It's another bidirectional one, just the same as these. On receive, it's going to be an RF preamp, but on transmit, it serves as the kind of post-mixer amplifier. Then it goes through pretty much the first thing that I showed you that I built in this radio, which was the switchable bandpass filters for 15 meters and for 10 meters. So, and that's where it stops. So if you look from a transmit point of view, it's pretty much all done. The only thing that remains are these 3 stages here. And I say 3 stages because actually there will be a 4th, because there will actually be a kind of pre-driver, because I've got to produce a larger signal to drive my driver, as it were. So there will be just a 1 transistor pre-driver going into the driver, then going into the PA, and then a low pass filter, and then there will be some switching there via a relay before you get to the antenna. So that's all there is to do. Oh, and lastly, of course, the power. So I've got to make sure that the right modules get power on transmit, and then the right ones get power on receive, etc. So that will be controlled, as I spoke before, by the Arduino in the software. But I just need to build the hardware for that. So that's pretty much done. And on receive, there's not a lot to build because pretty much we're picking the signal up here. Well, really, I could just stick an antenna into what I've already got. And assuming I biased the appropriate amplifier here, the signal will flow through. I would just need to build an audio amplifier, and that's all there is really for receive. What I've also got to do, of course, is on this audio amplifier is to join the connection to the Arduino for the S meter reading as well, and that might take a bit of tweaking. But that is essentially it. So there's not actually all that much to do. Most of the work has been done. So what I'm going to show you today is everything from the mic amp here going through right through to the bandpass filters. So, most of the transmit chain before we start beefing the signal up and getting some higher power. Right, okay, so here's what we've got. So we start off with a microphone, and that's just an external PTT, and that's feeding into the microphone amplifier, which you probably recall. I'm not sure how easy this will be to show you. It's glued, you can just about see it, on the back of here. So that's it. So the input is at the bottom. The output is coming out of this audio lead at the top, which is at the moment is doing a real scenic tour because it's going out here. It's going round the back of the spectrum analyzer, and then it's coming round into here. Now look at this. Check out all this stack. So this is pretty much the whole radio all stacked up here. So that's where the output from the mic amp is going into the input. So that board there, that second board down, that is the balance modulator, which I know is kind of hard to see, but you've seen it before. You can just about see the diode rings there. The top board is an RF diplexer, which is just cleaning up that signal, and this is the BFO signal from the SI5351, which is a square wave really, and I found that things work better if I fed it with a sine wave. So that's what it does. It just it filters out the harmonics and gives me a good 50 ohms termination on that port of the modulator. So that goes through to that. Then underneath that, I'm not sure how easy it is to see, you can just about see, yeah, those blue boards down there. So that is, and they're all identical, so I'll show you another one in a minute, but that's the first stage of IF amplification, bidirectional. And then the metal tin underneath, come around and get it this way, is the crystal filter. And as I said before, just check out that separate video I did on the crystal filters because that one is identical. And then from the crystal filter, what we have is we have a connection there, you can just about see, which comes into this bottom level. So this is IF amplification on the other side of the crystal filter. So we've got a crystal filter sandwich, basically, with a crystal filter in the middle, and then IF amps on either side. And that's then moving up to this next stage, which is the transmit mixer here. This one in the middle, which you might just about be able to see. Yeah, just about. And from the mixer then, so that mixes the IF up to the transmit frequency. And then this top one is the one I was talking about. So this is, well, it's actually two top to tail 20 dB tier amps, but one of them on receive is serving as the RF preamp, and the transmit one is serving as the post mixer amplifier. And then that is going out here, so this wire here going out around here, coming around, alright, okay, down to here, da-da, and this, of course, is the switchable bandpass filters, and we're not getting any further than that. So that's it. Right, that's what it all looks like. So actually, I was quite pleased that I, managed to stack it all in there pretty well. And so what we're going to do now is we're going to take a coaxial connection from the end of here, and we're going to do two different tests. Now, the first test that we're going to do is the traditional one. It's the two-tone test, and this is a test for the linearity of SSB transmission. So essentially what's going to happen is into the mic socket, I'm going to put two audio tones that are not harmonically related but are the same amplitude, and kick it into transmit, and we will be able to observe then on the oscilloscope how linear that transmission is, because the idea is really that it ought to be giving you the same response on both of those audio frequencies. And that will be apparent when you see the waveform on the screen of the oscilloscope. So that's the first test. We're going to do the two-tone SSB test. And to do that, we need a particular piece of equipment, and I will show you that before we do the test. So, some time ago, you can see when I was still a 2E0, so I was only an intermediate at the time, I built this little device. It's a two-tone audio signal generator, and I confess I built it and hardly ever used it, and I thought it's high time I actually did some proper two-tone testing on some of these radios that I am building. So yeah, what it is, it's not too hard really. You see there's a couple of potentiometers on there and a switch. And around here, I've just got a 3.5mm audio jack out. And if I just slip the top off, you can see hopefully what it looks like inside. So those are the potentiometers. So one of them is a gain control, which controls how much audio gain is coming out, and one of them controls the balance between these two audio tones. And you'll see it takes a little 9-volt battery, and it's very simple. It's just two transistors which are built on a bit of strip board there. And so yeah, works really well. If I can find the schematic, because it's a bit old, I'll link to it, but if not, you can just Google it and find them. There's lots of them around, and this is what we're going to be using to do our test. So I fired up the radio, and what I've done is I've connected the output of my two-tone audio signal generator into the input of the microphone. Now, before you do this, what you need to do is you need to make sure that your two tones are of the same amplitude. So you need to balance them, and that means using that top right potentiometer, and I'll show you at least how I did it now. So to set up your test, what you need to do is to make sure that your two audio tones are the same amplitude. So I just fed my output from a little signal generator into the oscilloscope, and you'll see clearly there my two audio tones. So I've just got that cursor, that top measurement line E, and you'll see I've tried to just tweak that balance potentiometer to get those two signals as close as possible to be identical, and you need to do that for the test. And once you've done that, then you're good to go. So now you're nicely balanced. All we do is we fire up into transmit mode. We're taking this line here now going in, and this is what we get. And that is not bad at all. That's exactly the kind of shape we want. There's no flat topping or anything going on there.
Now some of these little transitions here could be a little bit narrower here. This is pretty perfect, really. But yeah, I'm pleased with that. So that's showing a very linear SSB transmission, which is what you want to see. So just looking at this, I've run it again and paused it, as you can probably tell. But the things to watch out for is there's no flat topping, because sometimes if you overdrive a stage, you get this flat topping effect on the waveform there. We haven't got that, which is good. But the real thing are these crossing points. Now this one's excellent. This one's not quite so good. But really they need to be sharp and precise. You don't want them to be completely dead. You can see some forms with a waveform there's like a line, and then the waveform starts, and that's usually a sign that you've not biased it sufficiently. So we haven't got that. But neither do you want them too thick. This one's a bit thicker than I would like, but you can get them really thick, really. So this is not bad. I mean, for my ability to build things carefully, that's pretty good. But what I would say is it's only as good as your final amplifier. So what I mean is, yes, this shows that I've got a pretty linear system at the moment, but I want to be careful not to throw that away when I build my pre-driver, driver and PA. Because I want to try and keep that linearity throughout the whole of the transmit chain as far as possible to get the cleanest signal into the antenna at the end of the day. So, but by and large, that's not bad at all. So now that is the test. I'll show you the second test that I'm going to do. Now, just before I switch off the oscilloscope and show you the next test, I'm going to sneak another one in here just to measure the power that we've got coming out of the bandpass filters. Okay, so I'm just going to fire this up now. Hopefully you can see some of the figures down here. So I'm going to fire it up. Right, okay, so I've picked up the microphone now and just speaking into the microphone, and you can see the waveform coming up there. Dies away to nothing, which is great. Now, as I'm talking, you can see that probably we're peaking about, well, probably 760 we were peaking up there. I mean, if we, let's go for a conservative estimate and say about, well, if we had 650 millivolts peak to peak, I mean, we're in the region of 1 milliwatt output, which would be fine. In fact, probably a bit too much actually for the next stage. I might have to just slightly attenuate it, which is no bad thing actually. But yeah, so as you can see, that's working really well. Yeah, we're getting 768 peak to peak out of that. So that's absolutely fine. And as we've seen, it's nice and linear, and this will be great because I can plug this into the next stage now, possibly with the 3 dB pi attenuator in between or something, so I don't overdrive the input of the pre-driver. And yeah, it's looking very good. But the one thing I want to do now is to actually use my RSP2 from SDR Play and show you what it looks like and sounds like when you actually transmit this signal. And for my final test, I'm going to use my trusty RSP2 from SDR Play, software defined radio receiver. And I've just got just a little general purpose antenna on the end there, and that's going to be receiving the signal from right over here. So here's the filter module with another antenna, and if I can go back, you'll see, wow, look at that. I mean, that's about 40 centimeters. So I'm not going to head towards DXCC just yet with this, am I really? This is QRPPPPP. But that's good enough. So we're transmitting, and we're going to be transmitting at 21.100, and we're going to be receiving here, and then you're going to hear and see what that looks like then in the software on my Mac. So I'm using Cubic SDR, and you'll be able to see and hear for yourself.
1 2 1 2 1 2 testing testing. M0 NTV Mike 0 November Tango Victor station test. Okay, well, as you can hopefully hear and see, yeah, we're modulating, so this is great. And so we've got a nice upper sideband signal there at 21.100. And as I stop talking, hopefully you can see how the signal dies down to absolutely nothing. Fantastic. There's no carrier leaking through there, which has been the bane of many of my previous creations. And yeah, so it's looking and sounding great. Fantastic. That's exactly what we want to see. So it's my voice which is modulating that carrier, but we haven't got any carrier on its own leaking through. Brilliant. And that's just great. Now, the other thing you can see very clearly is that all the energy is contained within the upper sideband. So on the lower sideband, on the left-hand side of the 21.100 marker, is virtually nothing, which is exactly what we want. So that means that the crystal filter is actually doing its job and filtering out that opposite sideband. And so all our amplification is going into the one sideband that we do want, the upper sideband. So it makes a more efficient radio. So yeah, that's great, absolutely marvellous. And if you look at the top audio demodulation window, you can see, as I whistle there, a nice sine wave. So that, all in all, is really very good.
Well, there we go. We're transmitting. Fantastic. So the next video I make probably will show you a bit more of what I've built in the transmit chain. That's the pre-driver and the driver, and eventually the PA itself. But I've got to be honest, I'm just itching to build the audio amplifier so I can use it on receive actually as well. I have had a play around with some other ones I had lying around, but I haven't built the dedicated one yet, so that's something else I'll be doing. But all of that is for next year. Can I just thank you all, not only for watching this video, but for supporting my channel throughout the past year. And if you've liked this video, please give it a like. And if you haven't subscribed already, please do. And you'll find out when I make new ones. Thank you once again for all your support. And can I wish you all a very, very happy Christmas and a peaceful New Year. And I will catch you again in 2024. For some more home brewing. But until then, look after yourselves. Happy Christmas. Bye bye. 73.